KNIME Analytics Platform is the open-source software for creating data science applications and services. Intuitive, open, and continuously integrating new developments, KNIME makes understanding data and designing data science workflows and reusable components accessible to everyone. In particular, thanks to its graphical workbench, KNIME Analytics Platform is extremely intuitive, fully visual guided, and without coding needed. We are going to demonstrate for you such ease of use by building a simple workflow step by step in this video. The workflow we've chosen implements a churn prediction solution, but it could refer to any other classification task. We have documented the steps required for this workflow in annotations in the workflow editor. This is one of the main advantages of using a visual interface. We can document the workflow steps inside the workflow itself. The input files are available in this data folder in the KNIME Explorer. The CSV file contains the contract data for the customers, while the Excel file contains operational data for the same customers. Customers are identified by a customer ID key in both files. All we need to do is drag and drop the file from the local workspace into the workflow editor. This automatically creates the required reader node with most of the right settings to read the file. The configuration window opens automatically. After a brief check, we see that all settings are correct. Then we execute the file reader node and take a look at the output table. Next, we drag and drop the Excel file into the canvas. This creates an Excel reader node. Looking at the configuration window, we notice that the node did not recognize the first row in the file as the column names. We adjust this by enabling this option. We close the configuration window, execute the node, and we take a look at the output table. The next step in our workflow is pre-processing. First, we will need to join the content of the two read files. This typically requires a joiner node. However, if we are in doubt on what to do next, we can consult the workflow coach on the left. The workflow coach is constantly anticipating our next step. Here, the workflow coach is right. We need a joiner node for our next action. The joiner node allows us to blend data from different sources. We configure the node by selecting the key columns for the join operation and the type of join. We then execute the node and we view the result, which is now a single table containing all the contract and operational data for each customer in a single row. Our task is a classification task. Classification training algorithms often need classes as string. The churn classes are currently integer values, so we use the number to string node to convert them to string. Next, we use the Color Manager node to color the rows in our table. In this configuration window, we choose the colors according to state values. When we view the output table, we see that each row now has the color of its corresponding state. We add the partitioning node. We select 80% versus 20% relative partitioning and stratified sampling. Now it is time to train the model. A number of machine learning algorithms with different complexity degrees are available. For this example, we chose the Decision Tree Learner node just for demonstration purposes. We open the node's configuration window and choose our own settings, such as minimum number of records, number of threads, and binary nominal splits. We execute the node and we open the view. Here in the view, we can track all of the decision rules produced by our decision tree. Before we move on to scoring the performance of our model, we make sure that class attributes are equally distributed in the test data set, which we can do by adding the equal size sampling node. We set the necessary configuration settings and execute the node. Now we apply the decision tree predictor node to the balanced test set. After execution, a column with model predictions has been added at the end of the input table. Next, the scorer node matches the original and the predicted classes and calculates the confusion matrix and accuracy measures. We can also use the ROC curve node to score the model predictions. We choose churn as the class column, we arbitrarily set 1 as the positive class, and we plot the probability that a customer will churn. We execute the node and we open the view, where we have the ROC curve and the measure of the area under the curve. There are a number of visualizations to choose from. For this example, we use the pie chart node. We visualize the sum of churn predictions across states. We choose state as the category column, sum as the aggregation measure, and the predicted probability of churn as the frequency column. We execute the node, and we take a look at the output view. Finally, the PMML writer node saves the model in this output location. Now we have created a workflow to predict churn risk of customers. Using the intuitive visual user interface of KNIME Analytics Platform, we have created a valuable workflow in record time. There has been no need for coding, and it was easy to find and reuse the nodes to build the complete pipeline. You can try the platform yourself and build a workflow to create your own data science application. You can download the open source and free KNIME Analytics Platform at www.knime.com/downloads.